This is the Empower Podcast. Released May 4th, 2019. Episode 440.3. Interviews with Anul, AJ, Uriel, Steve, and Craig. We're back at KaiCon 2019. Who are you guys and what are you guys talking about just now?
Hi, my name is Anul. I'm from Mumbai, and I just did a talk on using FreeCAD to design components for use with KaiCAD.
I'm AJ Keller. I work for Neurosity. We make wearable computers, and I just learned about how to import a 3D model onto my KaiCAD and how to align the 3D model on the footprint.
What is the hard part about 3D with mechanical and electrical stuff? What's the deal there?
With mechanical, my biggest pain point has been the lack of proper design data from the manufacturer. So it all starts from there.
Yeah.
Without that, you can't make accurate models, and well, that's a problem.
How many manufacturers are actually providing the models? Because I know some of them do, but I don't know how.
No, in fact, all of them do. They always give a dimensional drawing.
No, but do they not give you step files?
No, not all.
Right,
of
that's
them.
what we're wrong. We want the finished product, right?
Yeah, I mean,
I don't think a lot of them
no.
do.
Right. That should be what's like.
I mean, they
used
all
over
have
and
it,
over
right?
again.
Like, I
Yeah,
hope.
exactly. It's not like they're doing the paper cardboard models in their
Yeah.
in their their facilities, you know.
No, but step files, not everyone.
Yeah.
And even the flat 2D drawings are not.
They're crappy sometimes. You can
Yeah,
say
they're
it,
pretty
that's fine.
crappy sometimes. You have to calculate back a lot of dimensions and.
Especially for even just footprints.
Oh, yes.
It's all relative measurements
Oh,
everywhere.
yeah.
Exactly.
He just pointed out we loaded like a 3D model onto my footprint, and he was like, "Oh, it's on top of your silk screen."
Yeah,
so it was like
that's
literally
great.
off, and we just caught it.
Yeah.
You know, I mean, it's not the biggest thing.
Oh
but-
yeah, centering it and stuff. Or
Well, it was
just the
centered,
size?
but it was sitting on. I had used silk to create the bounding lines of where I thought based on the mechanical
Right,
drawing.
right.
And then we loaded the step file they gave us, and it's over both of my boundaries.
Right.
That's good to check. Yeah.
Yeah.
The other thing we caught was when he imported the step file, it was so far away from the origin that it wouldn't be visible in his screen. So he was wondering where it is, and he couldn't find it.
Oh yeah.
And then we kind of zoomed out, and we say, well, it's way off origin. So that's like a design error,
Yeah.
because it wasn't made with the right coordinates.
And that actually has been blocking me for like 2 years.
Wow.
Oh,
So
wow.
AJ, what are you using this kind of stuff for? It sounded like you need 3D stuff because of your actual design constraints.
Yeah. So we're using KaiCAD to make print circuit boards that go in wearable headsets. And these wearable headsets have like 5 or 6 circuit boards. Some are flex, some are rigid. And connecting all of these together is really cool. But one big thing that I thought KaiCAD, I couldn't do with KaiCAD, is export the PCB exact STLs such that the design teams could then import them and create stuff and create casings for it and get it right on the first try. So a lot of what we end up doing is iterating and using 3D printing to then iterate, and that wastes time and money.
Right. Yeah, even if you're sending out for sending out for boards is a long time, and even 3D printing takes 10 hours, 12 hours, whatever. So
Yeah.
I remember, I recall you said STL. Remember, with 3D printing, you're mostly working with STL files.
Yeah.
But when you're doing CAD, you always want a non-mesh format. So STL is a mesh format.
Yep.
You want more CAD-specific formats like STEP.
So I shouldn't. Can you export step from the KaiCAD step up?
Yes, that's
Yes,
right. Yeah,
you can.
So that's the interchange format, really.
Yeah.
And so like STL is the finalized. It's kind of like I think about like a Word doc versus PDF. PDF's like an STL,
Yes.
right? You
Yes.
can't really go backwards from
Yeah.
that. But Word docs you can still.
So
And for a
STL
long
contains
time-
just the surface information. So there's nothing inside it. It's all hollow,
Right.
basically.
Which is what we care about for the
Yeah,
model, unless
exactly.
you're doing other stuff. I guess.
That's right.
Huh.
But for a long time, so like that's the thing. I think it was 5.0. When did the steps? I guess Maui. I remember on the forums did a lot of the step stuff at the beginning.
It had to
steps.
be 5.0 because there used to only be WRLs that worked.
Yeah. Those
Yeah.
weird.
Yeah, I never
formats.
heard of that format.
Was it VRMO? That's the one.
VRML is, virtual reality modeling language.
Oh, that's where it came
Yeah.
from. Okay.
So it was,
Man, VR has been a long time, huh?
Yeah, it's come from NIST actually,
Okay.
and was the
And
only
IST.
way in the old days of the web when you could have 3D models. They were all done with the VRML format.
So like for Second Life and stuff like that.
Yeah,
That's cool. So when you're doing like brain computer interface type stuff, I mean, you need to have that. Is it like because the shape of the cranium is changing so much, or just the rounded corners, or like what are some of the constraints that you
the
run into?
big thing is that we have to create a headset that is like one size fits most, right? So and everyone's head, it's amazingly
Different?
It's amazing how different every single person's head is.
Yeah.
And so we use flex printed circuit boards on the parts of the hardware that's actually bending and conforming to the head.
Yeah.
And we have like a little bit of rigid on the back of it that doesn't actually move. And so then it's actually able to grip and conform your head so that you're able to get contact on all the sensors that are all over your head.
That's great. What else is so both of you? I mean, like the mechanical side is there something that's still kind of missing that you'd be like, I wish I could have this, you know? Or is
Well, I
more
think-
making do as it is right now, you know?
Well, I think the fact that we quite often have to end up teaching ourselves a lot delays our projects a lot, because quite often we spend time just trying to teach ourselves how things get done.
Right. Well, then you have to give a
So-
workshop about it too, so that
Exactly.
takes a lot more time. you
Yeah,
know?
yeah.
So documentation.
So documentation, I mean, makers are already doing a lot of that work. They're putting out videos, but we want more of that. I mean, it's,
Yeah.
it's
Who's
never
doing it?
enough. Makers, I mean, hackers.
People.
Oh, just
people,
okay.
people are putting
Not a
stuff
company
out.
called Makers.
No,
but
no, no.
Makers.
No.
Yes.
People like us,
Yeah.
you and me,
Yeah.
who spend time, recording stuff so that others learn out
Absolutely.
of it.
Yeah.
But
But it's still in everyone's kind of website or feed.
Also,
It's
yeah.
not central
Yeah.
information.
I think
not
maybe
easy to find.
Yeah.
inside KiCad actually putting, like if there's something like stuck, when you're actually on the 3D screen, like not seeing your model, click here to understand
yeah, We need
how to
Clippy.
align that.
Yeah, we need a
We need
Clippy.
a Clippy for 2019.
No, but I mean, I was
Tracy.
stuck for a long time on this, and,
Yeah.
and he just imported it, and they were way apart, and I was like, oh wow. So,
That's a really, it's like a frustrating feeling too when like,
Well, you don't even know what to look
when
for.
you
I
don't
see
know what to
these
Google
videos,
for,
yeah.
right?
It
That is the
doesn't
hardest
show
thing.
up.
Yeah, and everyone's having so much success online with these like beautiful things. I'm just looking at this
Empty.
footprint. I'm like, oh,
Square turd that I made.
I'll try again. I'll try again in 2 months.
Yeah, I know, right? It's that really frustrating feeling. And
So I think this conference is amazing because it's just like put all these people together here, and I feel like such a novice. I've been able to do so much, but it's amazing to be able to learn these things. There's like 5 things I want to learn this week and cement them all and get that done.
Well, and it's a user
amazing.
conference, which is the one thing that
Yeah.
I usually go to developer or.
Sure.
And
Yeah.
this is like, no, we're all the same. Like we're all
Yeah.
trying to use it. We're
Well,
all
I
trying
think-
to learn.
I think even like the experts that you're talking about, like the people are like doing all these amazing things online. I think that's kind of like the Facebook effect as well, where it's like, well, yeah, you're seeing that end product kind of thing. It's not like you're not seeing all the words or the they maybe were struggling as well. It's like that's a tough thing to do, So,
Super fun though. I mean,
yeah, well, I'm glad you guys are here.
Given a choice, I'd always go to a KiCad user conference than a KiCad developer conference, for sure,
Wow.
because that's
Well, if
You gotta write C++
right?
in one of them.
yeah,
you know?
yeah.
Right now, we're writing
Yeah,
C++.
yeah.
Let's do this.
Yeah.
I'm good.
So the next time around, I think we should actually see if we can get FreeCAD on board as well, because
Okay, yeah.
the two are coming together
Sure,
close really well.
Yeah.
There's great integration, and I don't know who the FreeCAD devs are, but maybe you should reach out to
well,
them.
but if
and
it's
see.
his users, I mean, at least
Yeah, it doesn't
we can
matter.
get the
Yeah.
users together, right?
Yeah.
Yeah, do like an open source software,
Yeah,
general
yeah.
kind of like
Users,
user
yeah.
conference. Yeah.
Yeah, because I feel like a lot of the open source conferences are developers specific.
Like initially, I was very hesitant because I didn't know my talk was on FreeCAD, so I didn't know if it would be a right fit or even if it would be accepted for
great
the
fit,
conference. But I think this is something that needs to be.
What's the thing? Like, so like we
talk
talked about,
more
it's like
about
if we were just going to talk about like, here's what I click in KiCad, it's like, okay, that's not as interesting, but it is the stuff around it,
Yeah,
right?
yeah.
How you're using it, how you're struggling with it, like that kind of stuff is what I'm personally interested in because.
Yeah, otherwise it's just a video and like.
Yeah, exactly. Right, make that once, but it's like if you look at projects over and over again, you're gonna be like, oh my god, they do that way. Like that's something that you really need to.
Or you have the second person looking at like, oh, it's just off the screen. Like, oh, okay,
Yeah.
like that's not. You're not gonna upload a video saying like, well, I don't see my part, right?
Right, exactly. Yeah,
I wish someone did.
Right, no, exactly.
Right,
Yeah, but
right.
Yeah, quite often I've looked at videos trying to figure out a problem or a solution, and there's no mention of it at all. And I'm looking at the video for 5 minutes, and I say, "Come on, this is my problem. How do I solve it?" And it
Right.
ends, and I still don't know.
And then
I
there's
have
a
to go and
comment
hunt
like,
another-
oh, I figured it out.
Yeah, right. Yeah. Well, thanks for talking to us today, guys. That's
Yeah,
really
Thank
great.
you.
absolutely.
Thanks for
Hey,
having
thanks
us.
for putting this on. It's an
Yeah.
amazing opportunity.
Where can people find you online if you do want to
yeah.
be found?
You can find me online, best on Twitter at Anul ANOOL.
That's a hell of a hashtag or a handle you got there. That's
It's you.
And likewise, you can find me at Neurosity Co, NEUROSITYCO on Twitter, or Andrew J. Keller, JAY,
Nice.
and I'm around.
Awesome.
Thank you.
All right, thanks.
Thank you.
Welcome to the Amp Hour Day 2 at KaiCon. This is Alvaro, and I'm here with Uriel.
Yeah. Close enough.
How do you say it?
It's actually pronounced Uriel, but I gave up on that
Uriel?
many years ago when I moved to the States.
Okay.
Now we can just point and laugh.
I can relate. I'm from Mexico, so my name has been mispronounced many times. Can you tell us a little bit about yourself?
Yeah, so I'm for a living I'm a software engineer. I'm based in New York, and after going to Burning Man for the first time in 2011, I became an electronics guy in my spare time. So it means I go to work and I do engineering, and then I want to relax at home, so I do more engineering.
Yes.
And I heard of KICon. I think I actually found it over Reddit, and I suggested the talk, and it got accepted, and here I am.
Oh, what was your talk about?
So I have a project that had a very elaborate PCB for an LED matrix that I've done, and just doing it by hand and placing hundreds of components at angles of 37 or 217 degrees seemed very, very tedious.
Yeah.
So I did what every software engineer would do, and I automated it. And the result is an open source C# library that allows you to take a programmatic approach into laying out PCBs.
And so is this similar to the Skittle?
So Skill works on the schematic side of thing, and what it will eventually output is a netlist and a schematics file.
You're doing the layout side of
and
this.
And mine is the layout side of it. Yeah, it's all about footprints and traces and zones and.
So it does the placement for you, and it also does the routing.
It doesn't do it for you. You have to do them on your own, but it gives you a tool to do it programmatically. So if, for example, you want to place 200 LEDs on aligned lines, you don't have to drag them and make all of the mistakes of using your trackpad on your laptop. You can just write a loop to do it for you, and if it's the right tool for the mission that you have, it's actually a very efficient tool.
And it's a KiCad plugin?
It's not a plugin, it's its own sort of library, but the output that it gives you is a KiCad file that you can then go and edit manually. So you can do, let's say, LEDs or buttons or whatever you have a lot of, and then you can do the rest of the support circuitry by hand and still have the efficiency.
No, that's really cool. How long have you been using KiCad?
I think I've been using it for about 3 or 4 years, starting with version 4.0 and going as it advances.
What were you using beforehand?
I was not.
Oh, I was
doing manual soldering over perf boards, all of the things that makes the TSA very, very anxious when they see them.
Yeah. That's really neat. I'm trying to think. I haven't interfaced to KiCad files before. Is it pretty easy to do?
So the way I did it is I reverse and engineered the file formats that I have, more or less.
Okay.
And that's called a no.
We have Chris Gamble just joined us here.
But it's doable.
It's doable. If you've ever written any Lisp code, then it would look very, very familiar.
Oh, no.
If you have not wrote any Lisp code, then it's still not hard to look at.
We just asked how many people did raise a hand, and there's one guy in the back, and he's just like, oh, weird. They don't know. They can't see us. So I'm just saying that in front of the audience right now.
Yeah. No. Oh, wow. I thought it was a little more clear.
But no, the other few cool things about it is that once you have your circuit in a programmatic way, you can do a lot more with it. For example, the two things that I have so far that are very useful is exporting your PCB layout into OpenSCAD. So you can actually 3D print it, you can do manipulation on it, you can do other things based on it. And the other very useful thing is actually a very, very fast and cheap way to make a bed of nails. So,
because you already have...
Yeah, you just tell it, here are the edge cuts where I want the spring-loaded latches to catch it, and here are all of the footprints where I want the pogo pins to go, and it just auto-generates it in literally 5 lines of code.
With OpenSCAD?
With OpenSCAD for the 3D printed object, and it actually generates another PCB for the bottom layer, so it can route out all of the connection to you in a comfortable way. Automatically, yeah.
Oh, wow. Is this all on GitHub, or?
This is all on GitHub. It's in my repo. It's github.com/urielguy/KiCad Sharp, or just Google KiCad Sharp.
Okay.
And it's there, and let me know if you use it, because that's what keeps me developing it.
Oh, no, I mean, just bed of nail stuff. Not enough people do automated testing. I know I've seen the whole badge life thing is pretty big right now. Like people making conference badges, and everyone's programming them by hand, or you have like plug this thing in, and having a fixture. It's kind of the way industry does it, but it's kind of there's a barrier of entry for hobbyists, if you will, for smaller scale.
No more.
Yeah. Well,
Welcome to the future.
I have to check that out.
Yeah, here I'll show you one that none of the listeners can see.
Okay.
Ooh, cool. Yes.
So what about the? Oh, that was good. Nice. Yeah. What about the like? So as someone who doesn't use C# often, did you guys already cover that? Of like.
No.
Okay, so like I don't think I've ever used C#. How like what about that startup process? Like, is it going to be similar to like a C++ or like pretty simple environment? What does the development environment look like?
I think if you ever written any C-based language, C# will be very easy to pick up. I think that the best thing that Microsoft does is development tools.
Yeah,
And
like
once you
Visual Studio and stuff
Visual
like that?
Studio is amazing.
Yeah.
Visual Studio Code.
Yeah.
C# is now, by the way, also open source on Linux and Mac if you
Oh,
want.
great.
The last few months.
And this is not mono. This is like direct from Microsoft. Or?
No, not Mono. They open sourced it.
Oh, wow.
They rewrote the compiler in C# and released it for Linux and Mac OS.
That's fantastic. I did not know about that.
So, and they have that, and they have Visual Studio Code, which is an amazing open source idea as well. And I think that once you have a strongly typed language with good development tools, then the entry barrier for anybody using it, you just hit Control space or dot, and you just see all of the options. And for me,
That makes it easier. Yes.
that
The
with-
rigidity kind of helps at the beginning. You're saying.
Yeah, like
Yeah.
I think that with good development tools, C# is much easier than, let's say, Python.
Oh, great. Yeah, I guess. Yeah, you're not gonna see the spaces and all the.
Oh,
Oh,
yeah.
yeah.
It's-
No, but just
White
like the
space stuff.
tab complete when you're like you have an object and you say dot and then these are the three functions you can call with it.
Yeah, that is nice.
As a beginner, it definitely helps.
Yeah, that's cool. Well, that's great. I mean, your project is awesome. The build is like really nice. Did you talk about the bending of the PCB already?
I did not.
Yeah, let's talk about that real quick too. Because this, so like to describe what this is a ski mask with an array of LEDs, but it's a thin enough PCB that it was actually bent around
I see that.
the ski mask.
Were you wearing this outside yesterday?
Yes, I was.
Oh, so I did see you. Okay.
right,
Just
that LED person.
hook this up.
Yeah, and so basically it's a way to kind of show. It's like
Wow.
Garrett Mace has those LED.
Yeah,
glasses
but
as
this
well.
is machine like
But it's also see-through because there's cutouts in between
Yeah.
each pixel.
Yeah, it's a PCB made mostly out of holes.
Right, exactly. Yeah, Swiss cheese.
Yeah.
wow.
And then, but what about the bending process? Because that was really interesting to me.
So the bending process. So initially I tried going with a flex PCB,
Mm-hmm.
and that was both more expensive to manufacture, and it was actually a lot more fragile to
Yeah,
deal, and
right.
with the corners and putting it in, and didn't last very long. So what I tried next is I just went with 0.6 millimeter PCBs.
Mm-hmm.
And those are apparently, the radius here, I think it's something like 120 millimeters, and those just bend well enough around that. And what's holding it its place is actually each LED is glued to the lens of the goggles.
Mm.
These are like ski goggles, basically. Yeah.
Yeah, these are motocross goggles. Ski goggles
Okay.
are too fancy for this.
So it's a motorcycle. Okay, I see.
Yeah, like the
Yeah, I
double
couldn't tell you
lensing.
the difference.
Yeah, right.
Well, like any project, once you get into it, you
Yeah,
start
you learn
learning
all these-
of the,
Right.
the minute details. So
What if you're taking these to the playa too for Burning Man? I'm sure that
these
ski
were
goggles would be a little heavier and less
Ventilated?
ventilated,
Yeah.
right?
Yeah, these were born for Burning Man.
Yeah,
No doubt about
Yeah,
it.
exactly. Yeah, they look like you'd be able to be spotted as a burner from a long way away.
Yeah, these go well. Like that's I talked about it in my talk. I have another project called Touchy Blinky, which is a 15 by 6 interactive LED wall.
Oh, nice. Yeah,
And the main
15 by 6 feet.
yeah,
Oh wow.
and
Okay.
where
large pixels.
Yeah,
Yeah.
like they're all made of takeout containers and Bounty.
Yep.
And each one is also a button, but the problem with a 15-foot wall is that you can't take it with you,
Mm-hmm.
so people don't know that you did it. So this
Right,
is just
right.
like a smaller version.
It's
that you can
portable,
put
It's
on
like
your
a
face.
calling card on your face. Yeah.
Yes, exactly.
Yeah, that's
Like,
great.
oh, you like this? Go see the bigger one.
Yeah, right. Awesome.
Really neat.
Thank
Well,
you.
Thanks for talking to us. This
Yeah,
has been
this
really
is-
good.
Yeah,
Super
definitely.
cool.
Thanks for having me.
And where can people find you online?
I have a website called urailguy.com where I sometimes post stuff that I do, and on GitHub mostly.
Awesome.
Great.
Thank you.
Awesome. Thank you.
We're here at KaiCon. 2019, the only KaiCon there's been so far, and this is Alvaro with the Unnamed Reverse Engineering podcast, and we have our guest is.
I'm Steve Kulov. I own with my business partner HD Retrovision, and we make technologies for retro game consoles and other retro technology, legacy technology. We're trying to bring them into the new high definition age, I guess.
So this is like arcade, Nintendo, all.
Yeah, mostly home console type stuff. The arcade stuff's a whole nother beast. But I mean, we've done Neo Geo stuff, and that's
wow, yeah.
That even though the home version is a home version, it's still based on the arcade hardware. So.
And so are you? What are you doing with the hardware to get it into the modern times, I guess?
So what we've mainly made thus far is component video cables for Sega Genesis and Super Nintendo. And what they do is they take the raw red, green, and blue outputs out the back of the console, and they do a color space conversion all in analog circuitry, so like op amps. Operational amplifiers, they just do math on voltages basically, and then you get the output, and we send it through some high quality coaxial cabling, and so TVs with component inputs can get this really high quality signal that was mainly meant for Europe because they had like a weird connector called SCART.
Okay.
Yeah, so involved in that type of stuff is we had to write our own test software, so we had to make cartridges for Genesis and Super Nintendo.
Do like test patterns?
And they draw test patterns, and we measure all those voltages on the oscilloscope and get values and create approximations, averages, and so we know what gains to put on our analog circuitry.
So why keep it component? And like I know a lot of the new ones do HDMI, right? And then just go full for digital.
So this was conceptualized back in like 2011, 2012, and so there's two reasons. One, when we founded the company, we kind of wanted to split the task into two parts because we definitely do want to do the digital stuff.
Yeah.
So we first wanted to get the best analog output we could that's compatible with stuff people can use right now. So TVs that had it, people even use it on old CRT TVs that have component inputs, so they get really good quality off that too. So, and then the other half is like the HDMI output scaler video processor that would take any old analog signal, and so the two would interface to each other, and so we're in the process of working on that stuff right now. We just got an HDMI license last fall/winter, so we're looking at, or we're making progress on that stuff too.
And I assume a lot of this stuff, most of the documentation is by hobby or like by fans, right? Like how have you been dealing with that?
I've learned early on that most of the documentation online is flawed, so I've learned to just do all the measurements myself, do all the checks ourselves, the test software stuff. There were other test softwares, but I don't know how they were written. They weren't open source, but we needed to be certain that things were right because we're selling a product. We're asking people for money in exchange for this, right?
Yeah.
So it needs to be done correctly. I would not be comfortable just not knowing how that test software was written. And so we wrote the test software, we made carts, we published it on our site open source so people can see that we did the measurements correctly if they wanted to, and they could use it for their own projects and stuff like that.
And each different console, I'm sure it's a totally different way of writing to a cartridge. Like how...
Yeah, so we started with the Sega Genesis, which was kind of the easiest because there's a guy in France who made the SGDK, Sega Genesis Development Kit. And so it was, a bunch of C libraries and tools to compile for Motorola 68K, which is what the Sega Genesis or the Mega Drive they call in Europe and Japan. That's what they used. So that was the easiest one. And then I had to do the Super Nintendo stuff. And the easiest path to do Super Nintendo stuff was actually writing it in assembly. And so it's 68516 assembly. And I think the only other computer that used that was like an Apple computer of some kind. I forgot what generation Apple computer had it, but it's a very rare processor. It's basically a 6502
With
that
extra
you could
sauce?
put in 16-bit mode.
Oh, okay.
But I've noticed when I was writing the software, the assembler would have a hard time tracking of when you're in 16-bit and when you're in 8-bit, especially when you're jumping to subroutines and doing interrupts, where I just kept the chip in 8-bit mode
The whole time.
because
But, I
I
mean,
didn't
yeah.
really need speed. I was drawing a pattern up and then just leaving it there until somebody pressed another button to change the pattern.
And how do you know which instructions to use to draw? Like, so you have the development kit for that one, but are all these consoles is it fairly well known that?
There's some nice homebrew guides for writing homebrew on. I forgot. I think it was just SNES development, SNES development. .com or .org or something. There were some guides to get you started. There was stuff that wasn't there that we needed to figure out ourselves. There was a sound chip for Super Nintendo that is its own CPU basically, so you have to write a little assembly program for that CPU.
For sound.
For all we really needed was to check left channel and right channel if it was
Just
wired
beep,
up
beep.
correctly, because we weren't really doing anything with audio, but we needed to make sure that the white RCA cable was left and the red was right. So we wanted a little check in there. So it took a lot of time, but we ended up getting like a ding sound in the left and a ding sound in the right. Same thing with the Sega Genesis. We had to write our own, we had to track our own little program and our own little sound file and push it to the cartridge.
That's pretty neat.
Yeah.
And connectors in the back. Like, I know these were all proprietary. At least for the Super Nintendo, it was this weird shape. Are those widely available, or do you have to make your own?
So we kind of got lucky on the Super Nintendo ones because, so there's a lot of other cable makers. They just make the crappiest yellow, white, red composite cables, right? But they populate all the pins. So the RGB pins that we needed and the additional 5-volt pin, because our circuit needs 5-volt power, all the pins were there. And so, I mean, it took a while for our factory to find a source that we deal with a higher quality factory, and they need sourcing documentation, ROSE certifications and stuff like that. It took a while for them to find it, but they eventually found Super Nintendo /N64 analog connector. The Sega Genesis connector is a Mini DIN 9, which is kind of it's standard, but it's not that common. But you can still find, again, those people who are making the composite cables. They would use it. So there were sources there. The hardest connector it took to find was the Sega Saturn, which is a Mini DIN 10, and this PlayStation connector was the hard. PlayStation connector, all the third-party ones, all these companies were using for composite, had a force that was way too tight, and I was not comfortable with how tight it felt.
The insertion force was
the insertion and the removal force.
Okay.
And so I took a force gauge and I was doing tests on stuff, and I got my own specs, and we were trying to actually get a factory to make
just thinner or wider.
To make it ended up being the pins themselves. On the original Sony connector, there were these pins that are bent backwards and they're kind of springy.
Yeah.
And so the insertion force on those wasn't that much, but on these aftermarket connectors, just like a flat big piece of metal with where the springy U-shaped part would be, it would be solid metal. And so you're pushing all these 12 pins of solid metal in and removing it, and I was not comfortable with that. And we spent probably almost a year trying to find a connector, and we had to get a solution, like a compromise solution, which was we had our factory pull unused pins out of the aftermarket connector that had the white tabs.
Yeah.
And so we only used what we needed, and it was a middle ground where it was still a little tight, but it wasn't
But still
where
a
it
lot better.
feel like you were going to break somebody's childhood
Yeah.
console, right?
Wow. No, that's crazy.
Uh,
And I guess your main customers are streamers or like retro.
They're actually, I think our main customers are just us, like people.
Nerds.
I'm assuming 30s.
Yep.
Yeah, people in their 30s who grew up with this stuff kind of want to get back into it, and the emulator stuff just doesn't really do it for them. They want to pick up the controller.
And it's the same.
They-
It's the original console,
Yeah,
right?
right.
Still.
Yeah, they want to pick up the old controller. They want low input lag, input latency. They want to pop their cartridge in, and they want it to look decent on their newer displays. So that's mostly what it is. I mean, we get a lot of people who are like, they have families now, and it's like, this is the greatest thing ever. I get to play with my son or daughter or whatever. And it's pretty much people who like the nostalgia, but
Oh,
there's
cool.
younger people
Yeah.
who are into it too.
That's super cool. So how long have you been doing that?
I've been working. I've looked at Sega Genesis video signals probably since 2008, but it hasn't been consistent since then. I did a little bit in 2008, did a little bit more in 2011, 2012. We didn't found our company officially until 2014. That's when we had a Kickstarter in November of 2014, and since then it's been nonstop work.
This is
on
your
this
full time.
It is now, just recently, yeah.
Oh, that's cool.
But I'm surviving mostly on saved up money right now. So
Hopefully
yeah,
it goes well. Yeah, no, I people are always reverse engineering podcasts. So people ask reverse engineering, and then I keep telling people that looking at old gear that's not well documented and just figuring out how it works.
yeah,
Same thing.
yeah. I mean, another hard task we had to do is, we like I said, we wrote test software and put it on
Yeah.
the consoles, but there were 9 different revisions of the original Super Nintendo.
Yeah, how do you know the difference? It was
So
not-
we had to find all 9 of them. They're not explicitly known from the outside, so you have to crack open cases and look at the silk screen on the board. And so we had to. I still have them in our closet.
Are those differences well documented as well, or well known in the
No.
community?
No, not really. I have a friend and colleague who he runs RetroRGB.com. His name is Bob. He does a podcast with me and 3 other guys called the Retro Roundtable. He runs RetroRGB.com, and he tries to have a go-to place with all this information on it.
Oh, so this is all documented now on this.
I
or a lot of
I
it?
have not officially. We haven't officially released all our spreadsheets of anything yet, but it's something I'm open to doing in the future at some point.
Well, I'm sure
Probably when I have time and other
yeah,
stuff.
people would
but,
love that.
But yeah, it's definitely something. When we're in the middle of developing things, we like to stay a little bit quiet on stuff. But then once things are out there, we're really good with sharing, especially if you listen to our podcast. All I do is talk about design problems I've solved on stuff that I've been working
I'll
on.
have to check it out. Thank you so much. I think talks are starting again, but
Okay.
Thank you so much for joining us. Where can people find you online?
Me,
If-
nowhere
or you-
really. But
Oh,
our company does have a Twitter at HD Retrovision. My business partner Nick runs that. He's a social media. He's the social media guy.
That's fine. Yeah.
But there's also the retroroundtable.com is
The
it'll
podcast?
link you to the YouTube archives of our live streams.
Okay.
And other than that, that's
No,
really all.
no. Thank you so much for joining me.
Thanks.
We're back again. This is Alvaro, and
Peter.
our guest is
Craig.
Craig. Welcome to the Empower at KeyCon.
Thank you. How do you enjoy it so far?
This has been amazing. I think I've been to a lot of conferences for like industry before, and this is the first open source conference I've been to, and it's by far the most fun conference I've been to yet.
Can you tell us a little bit about yourself, what your background is?
Sure. So I'm an electrical engineer by childhood and school, and I'm a software engineer by childhood and job.
Okay.
So I started into electronics and software because I always wanted to make games, and I wasn't satisfied with just doing the software. I also wanted to make my game console. So back in high school, I followed a bunch of people online, had all these wonderful projects where you'd use a PIC micro to generate NTSC video signals, and some of them were nice enough to publish online about it, and it was really easy to get the free microchip PIC samples.
Yes,
and,
yes.
Somehow managed to make an assembly loop that spit out NTSC video, and then finally got more complicated with like a ARM microcontroller and a SRAM for a frame buffer and all that stuff, and writing the software. So it was like love at first sight with hardware combined with software. So haven't been able to escape it.
So when did you start using KiCad?
Let's see, 9 years ago now.
Oh wow.
I think
version
now
was
you
this?
win, right?
Yeah, you have the record.
I
so
don't
far.
even know if maybe I'm wrong because it might not have been out by then, but I used GEDA before that. And
Yeah, I tried to use GDA PCB first.
Yeah.
So, how do you did you switch from GDA PCB to KiCad because of features or?
Well, at my previous company that I worked at before going independent, we had access to all the CAD tools, like all the Cadence tools and stuff like that. And after using these really expensive tools, like crazy price tools, and realizing how badly they suck, and they still have terrible unintuitive UIs, they still don't do exactly what you want. And when I was doing stuff for hobby or doing stuff independent afterwards, I thought, well, KiCad has all the functionality, and everyone complains about its UI, but it's actually really good even when you compare against the commercial tools, because CAD UI is complicated. So, and it lets all your projects actually be free and open source. So that's cool.
Yeah, and so what do you miss from these tools that KiCad doesn't have, if any?
Like, maybe this is a very weird specific thing, but if you're using big BGA packages, your BGA, a lot of people don't think about it, but when you're doing trace length matching, you don't just match the length of the trace on the circuit board, but there's actually an even tinier
Of the
trace.
bond wire?
Yeah, bond wire, or like if it's a substrate, which is like a little tiny PCB inside the chip, that has a trace too, and it has some length. So, and the big boy tools would have tools for, you put in those
You
trace
add that
length.
like extra trim.
So basically, with the package, you define what the trace lengths inside the chip are.
Yeah.
That would be in the commercial software.
Yep, and if you're lucky, the manufacturer gives you a little thing you can import.
Oh, nice.
If you're lucky.
If you're lucky, there is a file format, exchange format for that.
Yep. So
that's actually a very, very interesting feature. It's like the people are moving into more and more complex boards. And
When we start doing
bigger and bigger
DDR3, DDR,
chips.
Yep.
So that's definitely useful.
yeah, and to be honest, nobody has really cracked the problem of how to handle the giant chips like that. Like, I was really impressed with Dave's talk this morning about using text-based schematic definition and Skittle, because I'm passionate about that, because I think it's the future, because today you have a schematic and it has a giant box with 1,000 pins, and they all have a label. And then there's another box on a different page with 1,000 pins, and they all have a label, and you got to find which label goes to what. And it makes the visual schematic not useful at all. So,
Yeah. For me, the comparison is HDL.
yeah.
It's like you want to design very complex digital. It's like, yes, of course, you can use some graphical user interface to pull traces, but everyone who I know who does HDL, sooner or later is like, this is just a mess and
Right.
rat's nest afterwards, so it's easier to actually write Verilog.
Exactly. Well, and you could use Verilog if you really wanted to for PCBs, but I don't recommend it. And I think we'll see a big evolution of PCB description languages, or maybe even just like circuit description language.
Especially for the really, really complex boards, like you
Yeah.
say, right? Because
Or-
for simple stuff,
Even if you have one FPGA with like
Yeah.
one DRAM, that's complicated enough that you want an HDL. And the crazy thing too is like every time you do a board with a DRAM like that, DRAM's all spec driven. Like there's I'm not innovating at all with how I
No, you
connect
just
my
use the design, right?
Yeah, exactly.
Because you tweak anything and forget about it.
Take the datasheet, copy exactly what they said,
Exactly.
and hope for the best.
Or it's kind of funny, even like small parts. Like today, what you do is you open the datasheet, you look at the application circuit, and you try to copy that into your schematic editor. Like, why can't that be a library that I just plunk down?
Yeah.
Yeah, but to be fair, it's like, especially with FPGAs, the datasheets more often than not contain even wrong reference schematics. I
Yep.
ran into that with even
Example
small
code
stuff.
as well, yeah.
Yep. Always the case. So,
So you mentioned you running your own business now, or do you do consulting? Or?
So, from 2010 to last year, I worked at a place called Deca Technologies as a semiconductor packaging company, and I worked on software for redesigning semiconductor package patterns on the fly there. And part of that was auto routing, and I had a huge passion about auto routing now after diving into the guts for it. And I left there last year, started a consulting firm, and since then, now I want to start a product company because PCB design is broken and it needs fixing. So, and there's a lot of pieces to it. Like, it was interesting. Dimitri from CAD Lab did a talk today, and he's doing another part of it, for diffs, visual diffs on PCB design. So
that would be nice.
I think it's happening.
Yeah, I can't wait for the moment where you go on GitHub and actually see the diff when you open this.
I know.
Of the schematic or the board design. Oh, I'm looking so
He had it.
forward to that. Yeah.
Yeah, it's amazing.
So you're working on auto routers?
Yeah, so there's all kinds of ways to attack the future of PCB design, but I had developed, appreciation for the intricate guts of auto routing algorithms while I was at my previous company, and so it's a rare position to be actually able to innovate on that, and it's a field that hasn't seen a whole lot of love in the last couple decades. Like, current state-of-the-art routing algorithms are still what we developed in 1992. Mm-hmm. So
we have a lot more cores now, like parallel.
Yeah. Well, we have cloud. Like, why does my routing have to run on my laptop and make it warm?
Hey,
why
good
why
point.
can't it go in the cloud? Why can't I use 100 servers? So
Yeah. Have you looked at, for example, NextPNR? The place and router for FPGA, the open source one?
no, I haven't, and I've been meaning to dig into that because that looks awesome.
there might be some interesting overlap.
It's interesting though because IC routing completely diverged from PCB routing, and it's gotten tons of love because you can't physically route an IC if you wanted to. So
Yeah, it's complex.
right, exactly.
And are you running these auto routers on KiCad?
So our plan is maybe we'll be the first commercial plugin for KiCad.
Ooh,
Wow.
Maybe, I don't know,
that would be cool.
but I think it could be awesome.
Open source ecosystems.
Like
right?
WordPress,
Yeah.
it's open source platform, and it has lots of open source plugins, but it also has a commercial community.
Yeah.
I think it could grow like that.
Well, I think that's great because then it actually funds the development of KiCad.
Exactly.
Like, it's
Well, like if you saw in Dimitri's talk, or not Dimitri, the Eisler talk, they had whenever you buy something through the company, they donate to KiCad. I think that's brilliant.
Yeah.
Oshpark's running that too.
Yeah, Oshpark is doing that, I think, and I think commercial users.
Yeah.
I donate my Eagle license fees to.
Right, right.
And then a lot of other people do that.
Yeah.
It's like we should share that on Twitter so that more
Right.
people do that. It's like
Big
imagine
donate button.
Yeah.
All about it.
Awesome.
All right. Well, thank you so much for joining us. Where can people find you online if you want to be found online?
So I have a blog that I sometimes post to at craigjb.com, but all my other contacts info is there too. So
All right. CraigJB.com.
Yep.
Thank you so much.
thank you.